Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue talking about my new project, a computer role-playing game which attempts to have more strategy than perhaps you often get in games of that type. So, in the last video, I showed you the starting situation of the board and the first thing that happens in the game. Essentially that we have this board representing a sort of future science fiction setting. We have this area in the middle with the skull icon, which is assumed to be under the control of sort of the villains of the story. The other areas are not, and they have a number which represents their vulnerability to being taken over by the bad guys. And then when we press this continue button, the areas immediately above, below, and to the left and to the right of this skull icon either get taken over, which in this case has happened to 3 out of the 4 of them, and they get that skull icon, or the number that they display increases, which represents that they've resisted being taken over, but they're now sort of more vulnerable to future attempts. So I showed you the first 2 passages of the 4 that make up this initial sort of part of the game, and I said that I would continue in the next video, which of course is this one. So I'm going to get onto the display. The display is pretty simple. It's a 5x5 HTML table. Each of these pictures, whether they be a skull or one of the numbers, is just a single piece of artwork or graphics which I made, and they're just displayed in a HTML table. So now I'll talk about what this means when we get down to it, but basically, as I've often said before, HTML tables have a lot of code, like they're quite long, but they're simpler than that length would suggest. So what we have is 2 for loops, one covering the Y coordinate, one covering the X coordinate. You'll notice that the Y coordinate starts high and goes down, whereas the X coordinate does what's more normal, which is starting low and going up. And that's because of how we number X and Y coordinates. Traditionally, X coordinates go up as you go to the right, and Y coordinates go up as you go up. In other words, this top row is Y equals 5, and then the next one will be Y equals 4, and then Y equals 3, etc. But when we print something on a computer screen, we print from the top down, which is sort of opposite. So because we're printing from the top down, we need to start with Y as a high value and then reduce it for the next, sorry, I keep picking the wrong bits, reduce it for the next row and then reduce it further for the next row, and so on. Whereas because the X coordinate is going up as we go to the right, and when we print something on a computer screen we print from left to right, well, we don't need to do that, and we can have the normal numbering. And each time we just have a TD, which is after every change in Y we have a TR, which indicates a new row, of course. After every X we have a TD, which indicates a new cell. And then we look at the vulnerability array, which is essentially storing these numbers. It's their vulnerability to being taken over, except that if they've already been taken over, the vulnerability is 0, which I did mention last video is a bit illogical. Shouldn't it be high if they've already fallen? Well, yeah, probably, but it doesn't matter because the player's never going to see it. And so we just look at the vulnerability of the particular cell that we're in. If vulnerability XY is equal to 0, that means that it's already fallen to the baddies in the story of the game. and so we display an image which is in art/fallen.png, and that is that skull icon. Otherwise, we display an image, we print another img command similar to this, img or square bracket img square bracket art slash then vulnerability xy, so that might be something like 45.png n square bracket. So all of these pictures with the numbers in them are saved with the name of that number. So in other words, the one that displays a 20 is saved as 20.png. This one that displays 65 is saved as 65.png, and so on. And that's basically how the display works, right? Now there's a little bit more there. There's a bit more code, and to explain that, I need to talk about the start variable. The start variable keeps track of where we are in terms of setup, because we're going to display this this board as we're setting up, which means that when we're on the display passage, the computer needs to know, well, where are we? What needs to happen next? Have we set everything up and we're playing the sort of main part of the game, or are we still in the process of setting up? And the start variable keeps track of that. And of course it starts, well, as you might predict, it starts at 0, and 0 means we sort of haven't done anything yet. So let's have a look at, and now this is the explanation for this div ID equals quote WHOLE end quote. So let's go down to here. After printing the relevant icon, we close off the TD, we close off the for loop, we close off the row, and we close off the other for loop. And so that's the code down to this point. Everything that I've highlighted displays the main part of the board. Now we have the code that deals with this continue button. So what happens, it says if start is equal to 0, which of course at the beginning of the game it will be, then we have an extra row. We have a single cell in the row. We have TD colspan equals quote 5 end quote, align equals center. So what that means is create a cell, that's the TD, colspan equals 5. The cell covers 5 columns. It's a special cell. Normally, of course, they only cover one cell and one cell high, but you can go colspan and row span to increase the size in either dimension. And in this case, I've made it encompass the entire width of the board, and I've set its alignment to be centered so that this button appears in the center of the board. Note that when you say colspan equals a number, you have to put the number in quotes, which is a bit counterintuitive. You'd think it'd be you'd think it'd be like that, but unfortunately we do have to put those quotes in. We have a button that doesn't have any destination, it just has text. So it says button continue, and before the slash button we have this replace command. And the replace command is what we use when we want to sort of trick Twine into changing the display without doing the thing that it normally does, which I'll demonstrate now. When I press restart and I choose OK, no, I didn't do it. Sorry. Normally when you go from one screen to another in a Twine program, it will sort of black out for a second and then fade in with the new display, and we don't want that. We want it to be smooth like that. It just sort of, it changes without blacking it out and bringing it in again. And when we want to do that, we use replace. So the first thing we say is which part of the screen, which part of the display are we replacing? And we say, well, we need to call a particular part of the display. We need to give it an ID. That's what's happening up here. We say div, which is just start a paragraph, ID equals quote WHOLE end quote. That's just a word that I picked. It's not a set command. I just use that because it's the whole page. So we could use replace to just replace part of the display, but in this case we're replacing the whole thing. So we go replace quote hashtag WHOLE quote, and what are we replacing the display with? Well, we're going to include expansion, which is the passage that I'm going to look at in a second, which governs the rules about the bad guys initially gaining some extra territory possibly, and increasing the numbers of the bits that they don't gain. And then we include display. So we're saying, well, we want you to replace part of the display, but actually the part of the display we want you to replace is everything from the very first line. So in effect, it's the whole display. But because it does that, it won't do that fade out, fade in effect, and that's the point of doing this. And what do we replace it with? Well, we want you to include the code in the expansion passage, and then we want you to include the code in the display passage, which of course is this passage. So effectively we're reloading the passage, but because we do it with replace, it won't do that fade out, fade in effect. So because we've included expansion in here, well, we probably want to know, how does expansion work? Well, this requires me to talk about another variable, which is targets, because the initial expansion of the bad guys is only the neighbours of that center icon, the ones that are above, below, to the left and to the right of it. And so we have this array called targets, which keeps track of the coordinates of the 4 places that are, as the name says, the targets of expansion. And we have it with the X and then the Y. So the center one is 3, 3, 1, 2, 3, column 1, 2, 3, and then row 1, 2, 3, because we count from the bottom. And so therefore the neighbours are 3, 4, 3, 2, 2, 3, and 4, 3. And so we have their coordinates stored in this targets array. That is the only place where the targets array is used. It's only used in this initial expansion. And then it's never used again, but we do need it. So, as the note says, initial expansion of the Empire. I haven't thought of a better name for the bad guys than the Empire. That, like the name of the game, Blaze, is something that I intend to change at some point, but inspiration hasn't yet struck. So we have a for loop that goes from 1 to 4, because there are 4 neighbours. We set X equals targets Z times 2 minus 2, and Y equals targets Z times 2 minus 1. So for example, when Z is 1, it'll multiply that by 2, which gives you 2, and subtract 2, which gives you 0. And then so the X value will be the 0th slot of targets, and the Y value will be slot 1 of targets. And then next time it will be 2 and 3. Next time so it'll be 0, 1, then 2 and 3, then 4 and 5, then 6 and 7. So we'll just read the X and then the Y, which is what we intended. We generate a random number from 1 to 20, and we multiply it by 5, because these things are displayed as percentages, but they're all in increments of 5. So rather than go 1 to 100, I decided, well, we'll just go 1 to 20 and multiply it by 5. It would have worked exactly the same either way, but that's what I did. Then we check whether W is less than or equal to the vulnerability of the target square, because 75 means a 75% chance that the baddies will take it over. 40 means a 40% chance, and so on. So if the random number is less than or equal to the vulnerability, then we set the vulnerability of that place to 0, which means that it has fallen, and we increment the variable fallen, because we need to keep track of how many have fallen to the bad guys, because that's one of the conditions for losing the game. If 13 planets are under the control of the bad guy, or 13 systems, are under the control of the bad guy, then you lose straight away. Otherwise, we set the vulnerability of that square to whichever is lower of this number that we rolled, or 80. 80 is a sort of hard upper limit. And then we set start equal to 1, because we have that special continue button, but we only want it to appear when start equals 0, because something else is going to happen once we've done that. So we have the continue button appear. We run that expand code. And part of that is setting start to 1. So when we go back to display, well, the button doesn't appear, because that button appearing is within an if statement, which is if start is equal to 0. And that is as far as I've gotten. That's how the game sort of sets itself up. And now we're ready for the first player decision. The decision is going to be that the player will choose one of the edge areas. It'll choose 2 of the edge areas to be bases, and those are places where the sort of pieces of the player, the agents of the player, they'll always appear in one of the bases. It also, if one of the bases falls, that's another condition for losing the game. So you want a place that's sort of going to be fairly resistant. Like in this situation, you probably wouldn't want to put it here, because it's got a pretty low number, 30, and it's right next to a skull. So that might not be such a good place to put it. It might be good to put it here in the 75, because that's a fairly high number, but it's near to the skull, so you can sort of get to where the action is. But that'll make more sense as we go further in the game and see how the strategy of the game works. But that is as far as I've gotten. Next video, I'll start talking about adding the bases and the main sort of play of the game. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.